Welcome to Module 3 of the Six Sigma Institute's Lean Six Sigma Certification curriculum, which follows both the Council for Six Sigma Certification and the International Association for Six Sigma Certification bodies of knowledge. A full copy of the Council for Six Sigma Certification's Book of Knowledge can be downloaded from the course description section for free. In this module, we will be discussing other process improvement and quality methods. This module will take approximately 30 minutes to complete. At the end of this module, there will be a 5-question quiz on the topics discussed, which you can complete on your own time at any time. You will also find several Six Sigma tools that you can download, including an Agile Scrum template and a Rummler branch template, both of which are Excel files. After completing this module, you will be eligible to take the White Belt certification exam. If you get a score of 70% or greater, then you will be automatically issued both the Six Sigma White Belt as well as the Lean Six Sigma White Belt certifications. While Six Sigma encompasses all of the tools you need to approach virtually any problem of process, familiarity with other types of process improvement and quality methods is also important. In this section, we are going to discuss the many other quality or process improvement programs that have been created over the years. These include formal programs such as ISO, programs no longer practiced like Total Quality Management, and several different proprietary programs such as Virgin's Customer Experience Management method and the Rummler Branch 9 Boxes model. Other methods include Lean and JumpStart, add value within a Six Sigma approach. Others may also be used by outside resources along with a Six Sigma project. Even if you don't use or work with some of these programs, you need to communicate with leadership and business partners who are more familiar with the other methods. ISO 9001 sets out the criteria for a quality management system and is the only standard in the ISO 9000 family that can be certified to. It can be used by any organization, large or small, regardless of its field of activity. In fact, there are over 1 million companies and organizations in over 170 countries that are certified to ISO 9001. This standard is based on a number of quality management principles, including a strong customer focus, the motivation and implication of top management, the process approach, and continual improvement. These principles are explained in more detail in ISO's quality management principles. Using ISO 9001 helps ensure that customers get consistent, good quality products and services, which in turn brings many business benefits. The standard tells the world that you have an active quality management system like Six Sigma or Lean already in place and have integrated it into the culture of the organization. Lean principles go hand in hand with Six Sigma. While Lean was originally developed for reducing waste in a manufacturing environment, the ideas of Lean process management can be applied to any process that involves the movement or creation of goods or services. This is true even if those services are virtual or digital, such as in a computerized workflow. One of the ways that Lean is similar to Six Sigma is that it is concerned with continuous improvements. Like Six Sigma, Lean provides waste removal tools so daily control and improvements can be made to a process. In fact, one of Lean's continuous improvement tools is called Kaizen, a Japanese word that means a change for the better. The purpose of every change in a Kaizen environment is to eliminate waste and or create more value for the customer on a continuous basis. It can be deployed within a project environment or in daily production. Like Six Sigma, Lean is more about an overall culture of quality rather than a single quality event. Total quality management is a phrase well known by anyone who worked in business in the last quarter of the 20th century. The total quality management approach to quality is one of the first formal methods enacted in business environments in the United States. Originally developed in the 1950s, total quality management didn't become popular with companies across the country until the 1980s as a result of the quality crisis. At one point, total quality management was so popular with executives and other leaders that it actually became something of a joke among certain workforces who believed that much effort and expense was expended on quality without an equal resulting benefit. In fact, if you remember from the last module, Jack Welch at General Electric felt this way. While total quality management programs were often somewhat lackluster when it came to results, the method was an essential stepping point to current improvement and quality methods such as Six Sigma and Lean. Six Sigma, Lean, and total quality management are all concerned with making continuous changes on both a large and small scale that bring an organization ever closer to a model of perfection. In the case of Lean, that model is a process that has zero waste. In Six Sigma, the model is a reduction in variation. Total quality management organizations often define their own version of perfection before working towards it. Business process reengineering, or BPR, is less concerned with incremental quality wins and more concerned with a radical change across an entire organization or process architecture. It is most often concerned with the technical processes that occur throughout an organization. Those processes might include systems, software, data storage, cloud and web app processes, and computer-based workflows operating and maintained by human users. As you can probably imagine, business process reengineering initiatives can be costly, which is why they are often deployed only when an organization expects exponential gains or has determined that current processes are obsolete or badly broken. Rumler Branch was pioneered in the 1980s by Gary Rumler and Alan Branch. They developed what remains a proprietary program used by their own consulting firm, but details of the method have been published and used by others. The method seeks to affect positive change in processes and organizations by using a set of practical tools to address business issues and process problems. One of the foundational concepts of the Rumler branch is known as the 9 boxes model. The model is created by a matrix of 3 performance levels and 3 performance dimensions. Performance levels are the performer, the process, and the organization. Dimensions are management, design, and goal. The process is split into 6 phases, which are planning, definition, analysis, and design, implementation, management of process, and process turnover. These phases are further broken down into 14 separate steps. Scrum is a project development method specific to agile programming endeavors in technical departments. Scrum is used when teams want to create a new technical product or integrate new developments into an existing product within a short time frame. Commonly, these projects last between 2 and 4 weeks. Scrum was developed as a programming and development teams needed a way to meet continuous technical design and improvement needs from other departments without substantially increasing programming, testing employee hours, or hiring more technical staff. It can also be used to drive faster times to production or market for software and application products. Scrum is a related concept to other process improvement initiatives we have discussed because many projects today call for some type of technical resource or change. While project teams are working to validate and measure, technical departments often simultaneously deploy Scrum concepts to meet development needs for the improvement project by the deadline. Customer experience management combines some process improvement tools with customer relations management. It was developed in the 1990s by the Virgin Group and became popular throughout the 90s and early part of the 21st century. The customer experience management method takes an outside-in approach to process improvement, focusing on what the customer wants or needs and how each process in an organization serves that need. The primary purpose of customer experience management is to align processes throughout an organization with customer satisfaction goals. As such, even processes without a direct relation to customers are defined in terms of customers. Like Six Sigma, customer experience management relies heavily on data. Organizations can't make determinations about customer goals and the success of processes without collecting and analyzing customer feedback. The advantage of customer experience management is that organizations are able to deploy customer facing tactics across the enterprise, which often results in enormous gains in customer satisfaction, loyalty, and of course, spending. JumpStart differs from the other programs and methods we have discussed so far, in that it is a fast paced method for identifying problems and solutions in a single session. JumpStart can be used within almost all of the other methods we have already covered as a way to spark discussion regarding processes or to identify possible solutions. It can also be used as a management tool for helping teams come to tenable solutions outside of project environments or in the absence of project resources. Because JumpStart doesn't take time for rigorous verification or statistical analysis on its own, teams should not use this method to enact sweeping changes or attempt to improve processes that could seriously impact customer experience or the bottom line. One major disadvantage of using JumpStart alone is that changes are sometimes made on a wait and see mentality, which is safe for many inter-team changes, but often dangerous for department or enterprise-wide processes, or for making changes to processes that are closely tied to regulatory or compliance rules. Some organizations make use of various project improvement methods. As a Six Sigma expert, you might have to champion your own method on occasions. In this section, we are going to discuss how to determine whether to use Six Sigma methods to solve a particular problem. We will go into more depth regarding the complexity of problems that we may face and how well they have been or can be defined. More importantly, we will discuss the financial factors that Michael Harry integrated into Six Sigma after he left Motorola. Because we are integrating Six Sigma and Lean into a single methodology, we will also talk about when it is more appropriate to choose to initiate a Lean initiative over a Six Sigma based project. Six Sigma is designed so you can begin a project even if you don't know the cause of the problem. When facing the unknown, teams cannot be sure of what the exact problem is. Rather, they only know that some metric is not performing as desired. An organization might have experienced a drop in its profits, which doesn't correct itself over the next several consecutive quarters. We can start using Six Sigma methods to seek to identify the causes of the problem, prioritize them based on business and customer needs, and work towards identifying solutions to correct whatever caused the drop in profits. While it may be easier to make business decisions when we know what the problem is before we begin, we can nevertheless use Six Sigma tools and methodologies to identify that problem and later convert that project into a lean initiative if need be. Even when a problem is understood, if it is wide in scope and not well defined, improvement projects can escalate in scope to a point where they become unmanageable. When working on a project, you may discover other problems with the same process, and if the project scope is not defined and managed accordingly, it can quickly get out of control. Many older organizations that have never used quality programs in the past may have a decaying infrastructure so widespread that improving a single process in incremental steps may seem futile, which is why we identify other problems we come across and prioritize them for future projects. Six Sigma includes controls for avoiding this kind of scope creep, so teams can make incremental improvements that steadily improve a process over time. If processes are complex and feature many different variables, it can be difficult to determine how to approach a solution, much less define and measure what success should look like. Knowledge of statistical analysis and process control lets teams approach the problems that involve enormous amounts of data and many variables. We can use the Six Sigma toolkit to break complex problems into separate and distinct issues that can be dealt with incrementally with Six Sigma or through a lean initiative or Kaizen event. Through analysis and graphical representation, complex ideas can be distilled to specific hypotheses, premises, and conclusions. When Michael Harry left Motorola, he modified Six Sigma to include financial factors because these play an important role in an organization's decision process. As a result, Six Sigma's statistical process control component lets teams make more accurate assumptions than almost any other method that we have discussed. As a result, it is appropriate for situations that are closely tied to revenue or cost. All too often, a single tiny change in an organization or even in a process can result in millions of dollars in gains or losses. So teams must validate assumptions with an extremely small margin of error. Guesswork, basic research, and even years of experience cannot do that as accurately as a properly implemented Six Sigma initiative.